Reminder, this does not cover all the materials. You have to study all the packets. This should say 3.1 through 3.7. So you're going to want to take a look at those two packets, okay? So this first problem, the graph below shows one period of a periodic function. Sketch the rest of the graph on the given axis. So if I look here, so it's back up at 8. So at 1, 2, 3, 4 more, it'll be down here. Let's see, at 2 more. So I can make some of these points pretty accurate. So it's going to go to here. So it's going to look something like that. So from 20 to 24, well, I know that this is 0 to 8. So the next cycle will go from 8 to 16, 16 to 24. So 16 to 24, so 23, 22, 21. Here would be 20 to 24. It would be increasing. All right, so the measurement of an angle is in standard position. In which quadrant is the terminal ray? Well, this is greater than 2 pi. So if I subtract 2 pi, I get 4.6 pi. If I subtract another 2 pi, I get 2.6 pi. Minus another 2 pi gives me 0.6 pi. All right, so again, that's 6 over 10 pi. So that's a little bit more than pi over 2, right? Because 5 over 2, so that would be right here. Because again, this is pi and this is pi over 2. So it's in quadrant 2. All right, well, let's add now to make it positive. So plus 2 pi would be negative 0.3 pi. Plus 2 pi would be 1.7 pi. Okay? So again, I know that this is 0 pi over 2, and this is 3 pi over 2, which is the same as 1.5. So I know that it's somewhere down here in quadrant 4. Okay, this next one here, the radius is 8.2, so this is 8.2, and the length of an arc subtended by an angle is 37.63. And again, this is all in, let's see, we're supposed to find the angle. Okay, so our angle measurement, and this is something we didn't talk a lot about, it is our arc length over our radius. Okay, so this would just be 37.63 divided by 8.2. So that would tell us it's 4.589 radians. So this next one, it's the arc over our radius. So we have 5. Oh wait, but what do we know here? Let's read this. We know our angle, so we have 0.56 pi radians equals our arc length, which we don't know, over 5.27. So solve that by multiplying by 5.27. And we have that arc length is 9.271. Okay, this next one, an angle of 3.56 radians, and the length of an arc subtended by an angle is 5.2. What is the radius? So again, our angle equals over our radius. So our angle is 3.56, 5.2 over r. So let's see, times r times r. So r times 3.56 equals 5.2, divided by 3.56, and r equals 1.46. Okay, so the next one, we have to come up with these sine, cosine, tangent. So if I make this a triangle, I go back negative 3.1 and down negative 0.7357, and we know our radius is 8. So SOHCAHTOA, so negative 7.375 over 8. Our cosine, adjacent, over 8. And then our tangent, negative 7.375 over negative 3.1. And again, 2 negatives make a positive. And again, you could turn those into decimals. So this next one's the same thing. Straight down, our radius is 1, so negative 0.95 and 0.312. So opposite over hypotenuse, so 0.312. Adjacent over hypotenuse, so negative 0.95. And then opposite over adjacent. If I divide that out, I get approximately 0.328. Okay, so the next one, find the cosine. So cosine at pi, so negative 1, 0. Cosine is our x, so that is negative 1. The sine of pi over 4. So here's pi over 4. Let's see, root 2 over 2 and root 2 over 2. Sine is our y value, so we'd have root 2 over 2. Cosine of 2 pi over 3. So again, that's like 260 degrees, or 120. So right here. So let's see, this is pi over 3, so opposite is root 3 over 2. So half, but this is going backwards, so it's negative. Cosine is our x, so negative half. 7 pi over 6. Well, that's a little bit more than pi, so here's 7 pi over 6. So there's pi over 6. Opposite, 1/2. It's going down, so it's negative. So this side would be root 3 over 2, but negative. Cosine is x, so negative root 3 over 2. Sine of negative pi over 6. So that would just be going backwards. So there's pi over 6. Half, negative, it's going down, and root 3 over 2. Sine is our y, so negative half. And then 5 pi over 4. So we're going backwards. So I always count this out. So there's 1 pi over 4, 2, 3, 4, 5. So pi over 4. And these are both root 2 over 2, but our x, it's going backwards, so it's negative. And cosine is x, so negative root 2 over 2. Okay, so for the next couple problems, that it is in standard position. A circle is centered at the origin with the given radius. What are the coordinates of the point of intersection? So I know it's 3 pi over 2 and our radius is 6. Well, this would just be the coordinate 0, negative 6. So 5 pi over 3, so 5 60 degrees is, so 1, 2, 3, 4, 5. Our radius is 10, and this is pi over 3. So again, x equals our radius times our cosine of theta. Y equals our radius times our sine of theta. So opposite pi over 3, that would be negative root 3 over 2, and this would be half. So x equals 10 times half, so that's 5. Y equals 10 times negative root 3 over 2, so that's negative 5 root 3. So we have the coordinate 5, negative 5 root 3. Now the next one, we have to find r and theta. So if I was to graph this, I go over positive root 3 and down negative 1. So what are these similar to? Well, this is similar to root 3 over 2. And this is similar to negative half. Well, how did we get from here to here? Well, it looks like in here to here, we multiplied by 2. So that means our radius is 2, because this to get here to here is times 2. Here to here is times 2. So that means our radius is 2. And now we know this angle, it's opposite half, so that's pi over 6. And what is it in this angle? Well, that is 1 less than all the way around, so theta is 11 pi over 6. All right, and the next one, let's see if we graph this. We have negative 6, positive 6 root 3. So again, so this side, I'm thinking root 3 over 2, how did we get to 6 root 3? And then this other one would be negative half. How did we get to negative 6? Well, to me, that looks like we multiplied by 12. So our radius is equal to 12. And let's see, this is root 3 over 2. This means this is pi over 3. So what is that? How many pi over 3's to get there? That's 2. So theta equals 2 pi over 3. Sorry, this should be our radius is 12. Okay, describe what is happening, and so on the cosine. So I'm going to draw our cosine, 1, 2, 3, 4. So that's 2 pi, pi over 2, and this would be 3 pi over 2. Cosine starts high. So from pi over 2 to pi, the concavity, so it's concave up, and f is decreasing. And then from 3 pi over 2 to 2 pi, concave down, and it is increasing. So now we're going to do the same thing for the sine. So sine is 2 pi, pi over 2, and 3 pi over 2. Sine starts at the center. So from 0 to pi over 2, concave down. And the graph itself is increasing. And then from pi to 3 pi over 2, concave up, and our graph is decreasing. Okay, so the next one, write an equation of the sine function. So let's see, our sine. Here's our midline. It's at -1. Our amplitude is 2. And it's sine, and it doesn't look like it's shifted because it started up. So then we just have to worry about our period. So a full wavelength goes to here. So that is 2 pi. So 2 pi over b equals 2 pi. So b equals 1. So again, if there's no horizontal shift, it's just this. So y equals 2, the sine of x, minus 1. So our next one, it looks like our midline's at 0. Our amplitude is 2. And this is a cosine. Well, cosine starts high, so there we're good, but our period is just right there. So 2 pi over b equals pi. So I could put it over 1. So 2 pi equals pi times b, so b equals 2. And there's no shift, so this would just be our amplitude is 2, the cosine of 2x. And here's the sine. So our midline is at 1. Our amplitude is 1. And let's see, what is that period? So here to here, there's a period length. So 2 pi over b equals pi. So again, b equals 2. But sine usually starts in the center. So this is 1. Sine usually starts here, but it shifted over. So it shifted over pi over 4. So our equation, 1 the sine of 2x minus pi over 4. And then we would have a plus 1. Okay, so the next couple, it looks like we are going to be graphing some of these. So again, we have to factor out the 5. So 3 the cosine of 5x minus, if we factor it out, we have to put it in the denominator. So our amplitude is 3. Midline is 0. Period is 2 pi over 5. So that makes this 5 over 2 pi. And our minimum would be 3 and -3, and to the right, pi over 5. All right, so this one, our amplitude is half. Our midline is -2. Period, 2 pi over 4, or pi over 2, which makes our frequency 2 over pi. And our max value, so it goes up half and down half from our midline, and then there is no phase shift. So now we have to graph some of these. All right, so up 2, down 2. Our b value is 1, so 2 pi, our period is 2 pi over 1, which is 2 pi. All right, and so let's see, it's going to start at our amplitude, and then it'll be back there at 2 pi. So right in the middle, our cosine has to go low, right? Because a cosine, here's our normal cosine, so that means it's got to go here. So mid, low, mid, high. All right, this one has a little bit more. So our amplitude is 3. Our period is 2 pi over 2, which is pi. And it moved down 1. So I'm going to go down 1. Our amplitude is 3, so 1, 2, 3. 1, 2, 3. Okay. Sine starts in the center, and it comes back here at pi, right? Because that's our period. And I know a sine function. It's positive, so center, high, center. So here's a full cycle. So it's got to go in the middle here. Then it would go high, low. So high, middle, low, middle. Low, middle, high. Oops, high, middle. And we have it. Okay, so the next ones have some right-left shifts. So again, here's our amplitude. Ooh, and we have to factor this one. So let's factor out the half. -3, the sine, half x plus pi over half. And what is pi divided by 1/2? Well, that's 2 pi, okay? So our amplitude is 3. Our period is 2 pi divided by 1/2, so that's 4 pi. And then we would say it moves to the left 2 pi. So 3 and -3. Sine starts in the middle and it goes down. So I got to think about this one here. So sine starts in the middle. And now our period is 4 pi. So that means it's back here at 2 pi. So I could graph that. So at pi, it's at the low. And then it would be high and middle. But what happened to this one? It moved to the left 2 pi. So this one becomes here. This one becomes here. That one would become here. So it looks like it shifted over. All right, and this last one. So we have 2, the cosine of 2x minus pi over 2 minus 1. So our midline is -1. We go up 2 and down 2. Our period, 2 pi over 2 is pi, and to the right, pi over 2. So cosine usually starts high, mid, low, mid, high. And again, I know that this is pi. So it starts high, it comes back at pi. So right in the middle, it's got to be low. All right, so there it is. But what happens to each of these? To the right, pi over 2. So that's 2 tick marks, right? So this one would go here, 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 here. And now I bet I could just keep it going. So it's going to go low, mid, high, mid, low, mid, low, mid, high, mid, low. Okay, so the next one here. Suppose you were riding a Ferris wheel. After everyone is loaded, the wheel starts to turn and the ride lasts for 105 seconds. Your height above the ground is modeled by this equation. You don't need a calculator. So what is the period? So 2 pi divided by pi over 10. And again, to divide fractions, 2 pi times 10 over pi. So it's 20. So what does the period represent? So it takes 20 seconds for a full rotation. What is the frequency? 1 over 20. So what does that mean? It makes 1/20th of a rotation every second. What's your maximum height? Well, our midline's 65, right? And it goes up 50 and down 50. So that would be 115. So 115 feet. Our minimum would be 15 feet. How many circles does the Ferris wheel make during a ride? Well, it takes 20 seconds to do one. So what is 105 divided by 20 is 5.25 circles. So how high are you when the ride begins? So this is like calculating h of 0. So on your calculator, and again, you want to make sure you're in radians. 0 minus 4 plus 65. And you should get about 17.477. And when your ride stops, you do the same thing and plug in 105 for your x, and you should get 80.451 feet. Okay, the next one. The following data can be modeled by a sinusoidal function. Use the data to answer each problem. So let's kind of see, this looks like this is a minimum. Where's a maximum? This looks like it's a max. Here's another minimum. And 49 is another max. So the period. So to get from a minimum to a minimum, 2 to 12, 7 to 17, our period would be 10. So our frequency is 1 over 10. The vertical shift, our midline, well, it looks like a minimum is around negative 10, and our max is about 50. So 50 plus negative 10 divided by 2 is about 20. And then the amplitude, so 20 to 50, 20 to negative 10 is about 30. Now, you can create a model here. So we said we're filling this in. So our amplitude, we said, was 30. The sine, our period, 2 pi over b equals 10. Put 10 over 1, so 2 pi equals 10b. So b equals pi over 5. And then we know it goes up, our midline is at 20. So if it's a sine function, sine usually starts in the center. So that's halfway between our max and min. So that would be about right here at 4.5, right? But it starts over here at 0, so that moved it to the right 4.5. So you'd say x minus 4.5. And then again, you could type it into your calculator and see what it is, but just remember, usually your calculator has it distributed.